Hi there, folks. Today we're looking at the distributive property, and that idea of distributing things, if you think about like distributing things to a class or something like that, you're handing that thing to each person in the class. So if I were to distribute a worksheet, everybody gets the worksheet, okay? And the distributive property is kind of the same thing, but we're giving away multiplication to everything that's inside the parentheses. And so when you see the distributive property here, it looks kind of like this. But what it's showing us is it's saying, hey, we're going to take this multiplication because this says A times this whole thing in parentheses. That's multiplication right now. And we want to distribute that multiplication. In other words, I want to give this multiplication, this times A, and I want to give it to this guy and say, hey, let's do A times that thing. And then I want to give it to this guy also and do let's A times that thing. So what we're doing is we're distributing. We're giving away that multiplication to everything that's in the parentheses. Okay? That's the idea here. And a lot of times we show this by just drawing these little arcs and saying, hey, I'm distributing. That's our way of showing that we're giving that multiplication away to everything. For example, if I look at this first one, and in this first one, right now I'm multiplying by a 3, but I want to distribute that multiplication. Instead of multiplying by a 3 outside, I want to give that multiplication away to everything inside the parentheses. I want to give that multiplication of times 3 to this first guy, to that 4x, and I want to give that multiplication away to the 1. And the way we decide what gets the multiplication is always separated by addition or subtraction signs, okay? We call those terms, all right? So each term gets this thing, okay? And so I give this multiplication away. I say, hey, you know what? I'm going to do this times 3, but I'm going to give it to the 4x. And then I'm going to take that times 3, and I'm going to give it to this positive 1, all right? I'm giving that multiplication away to everything in the parentheses. And now I actually do the multiplication. 3 times 4 is a 12, so that's 12x. 3 times 1 is a 3, and that's it. All right? And so if we talk about simplifying, the distributive property is one of the ways that we simplify this thing. Okay? If I look at the next one, again, I want to distribute. I want to give away that multiplication. Right now I'm multiplying by -2. Let's give that to each of these things. Okay? So I'm going to give that multiplication to the x, and I want to give that multiplication to this -5. Okay, so again, I'm distributing -2, but it's times a -5. Make sure you keep all the same signs that you had. If the 2 had a minus sign in front of it or an opposite sign in front of it, and the 5 also had one of those, well, now I have 2 of them. All right, so I have a -2 and a -5, and it's really important that we keep all of the signs. Okay, so here -2 times x is -2x. Here negative times a negative is a positive, and that's a 10. Okay. If I look at the next one, there's a number written out front there. I can't see it, but I know that it's there. All right? There's a 1 written right here. Anytime we don't see a number written, it's an invisible 1, and it just so happens that that's a -1 because of that sign. So now, once again, I'm going to distribute the multiplication. And some of you aren't going to write this step every time, like the -1 times 4x. And then the -1 times the -3. Again, make sure you keep both signs. Don't lose anything in the process of the distributive property. And most of us are going to start to get used to this and cut out this step where we're showing the -1 twice. We're just going to do the multiplication in our heads. If you're not there yet, that's okay. -1 times 4x and -4x. Here, that's a +3, a +3. All right, negative times a negative is a positive. So again, we're just giving that multiplication away. One of the contexts in which we use this is going to be simplifying certain things. And so it's important for us to understand combining like terms, all right? Adding and subtracting terms that are alike. And from a broad perspective, like terms are terms with the same variables and the same exponents, okay? So they have the same letter, and those letters have the same exponent, the same little number written at the top, all right? We can only add or subtract things that are like terms. All right. And when we can add or subtract them, we just add the numbers like we normally would, and the variable part just stays the same. All right. For example, if I look at this guy, we're looking for like terms, same variable, same exponent. So like here, this one doesn't have a variable. So the thing that would be a like term is anything else that doesn't have a variable, like this guy or this guy. Okay. So those are all like terms. And then I see a 4x. So something that would be a like term with the 4x would be anything else that also just has an x. And so when I look at the next term, the -3x squared, see, that's different because it doesn't have the same exponent. But this one, that's just an x. So those are like terms. Anything that looks the same in terms of the variable portion, those will be like terms. And then these guys right here, the 3x squared. Well, The like term would be anything else that also has a 3x squared. Okay, and so if I start kind of putting those in groups, I'm going to start with the thing with the biggest exponent. It's always easier to get those out of the way first. So like for this one, I would say, okay, this is a minus 3x squared and a positive 5x squared. And again, just ignore the variable. Let's just say, hey, if I had a negative 3 plus a positive 5, that would be a positive 2. And then that variable part just tags along for the ride, x squared. It's kind of like when we get common denominators, the denominator stays the same. When I find common terms or like terms, the term kind of stays the same. Yeah, I add the numbers, but the variable part stays the same. And now I look at the x's. Right here, I had a positive 4x, and then I have a minus 2x. And so again, ignore the variables. Just look at a positive 4 and a negative 2, adds up to a positive 2. And now the variable tags along for the ride. It's just an x. Okay, that part stays the same. And then these last guys, a positive 22 and a negative 14. Well, that's going to give me a positive 6, but then a negative 12 in addition to that gives me a negative 6. Okay, and if you need to take that off to the side and do, the 22 minus the 14 and then the minus 12, that's okay. And write this out and say, oh, that's a positive 6 and then minus 12. All right, that's a negative 6. Okay? But that's the idea of combining like terms. We're not going to use that to this degree just yet. All right, you'll deal with some of these more complicated things a little bit later. For our purposes right now, it's just really important to make sure that we only combine things that have the same variable. All right? And here's the context in which we'll use that. Stuff like this with our distributive property in mind. So something like this guy here, if I was doing the distributive property, if I was distributing that multiplication of x, I'm going to do x times the 3, and then I'm also going to do x times the 7. Well, that gives me a 3x and a 7x, which now those are like terms. I can combine those into a 10x. And I can do that because it's the same variable, because it's an x twice. All right, I'm allowed to do it in that context. All right. The other thing that's interesting here is I could have followed order of operations for this one. Look at this. Inside the parentheses, 3 plus 7 is a 10. And now x times 10 is a 10x. And notice I get the same thing. This is why combining like terms works. It's because combining like terms is a special case of like the distributive property in kind of a weird format. All right? And so just keep that kind of stuff in mind. If the terms are the same, the variables are the same, we can add them up just like we add numbers, but the variable part stays the same. Okay? If I look at the next one. Again, only things with the same variables can be combined. So here, this guy and this guy have the same variables, the 4x and the negative 6x. And make sure you include the signs here. All right? A positive 4 and a negative 6 gives me a negative 2. And it was an x, so I keep the x. But I can't add that 3y because y is not the same variable. So I leave it as a plus 3y. Okay, that part just stays the way it is. I have nothing that I can add to it. All right? If I look at this one, again, only things with the same variable would be considered like terms. So in this one, the y's, well, those are the same, so I can add those together. So a 2y and a 4y, again, just add the numbers. 2 plus 4 is a 6, so it's a 6y. And then here, the x's are like terms, a negative 5x and a negative 2x. Again, include the signs. Negative 5 plus negative 2 is a negative 7, so I'm going to write a minus 7x. The variable part stays the same. And then this guy at the end, that 8 doesn't have anything to combine with, so it just stays the way it is. Plus 8. Okay? And so this idea of combining like terms becomes really important, especially combined with our distributive property when we're trying to simplify certain things. Okay? So for example, what I want to do here is I want to simplify the expression. I'm going to use the distributive property, and then I'm going to use combining like terms. Okay? I'm going to use these two things together so that I can simplify expressions as far as possible. All right? For example, if I look at this first one, again, anytime I see multiplication with parentheses, that's where I would use my distributive property. All right? So if I kind of ignore this second half of this, ignore this minus 4x for a second, only look at the first part of this, this is my distributive property. I want to distribute that multiplication. And so that's what I do. I distribute the multiplication. I do 4 times the 2x, and then I do 4 times the 5. And then that minus 4, that just kind of tags along for the ride. Just let him hang out at the end there. But now I do the multiplication. 8x plus 20 and then minus 4x. But now I want to combine like terms. I look for things the same, and I see this 8x and this minus 4x, they have the same variable, so those are like terms. And since they're like terms, 8x minus 4x gives me a 4x. So they combine to a 4x. The 20 doesn't have anything to combine with, so it stays the way it is. Okay? I'm using my distributive property, but then I'm also combining like terms after I'm done that. Okay? If I look at this one, again, I want to distribute this negative 6. And once again, make sure you include that sign. It's negative 6 times x, and then negative 6 times that negative 2. Okay? Include the signs. If there was two minus signs, a minus sign with a 6 and a minus sign with a 2, don't get rid of them. All right? Keep them there. Okay? So now that gives me a negative 6x. Here that gives me a plus 12. All right? But now I have another set where I can use my distributive property. Here's my distributive property again. And this time I'm going to include that plus sign here. So now I'm going to do the 5 times the x. And here I want to do the 5 times the 3. That's my distributive property again. So that's a 5x plus 15. And now I look across and I combine like terms. I say, hey, look at this. This negative 6x and this 5x, I can add those together. A negative 6 and a 5 gives me a negative 1, so it's a negative 1x. And you can write the negative 1, or you can just write negative x. That's okay. Here that gives me a 12 and a 15, and that's a 27. So I'm using my distributive property, but then I'm also combining like terms to continue to simplify this thing, okay? And also keep in mind that many of you are probably going to start to jump right to this step with your distributive property, and that's okay. All right, you're going to skip that step after you get used to this, all right? You're going to jump right to this, and if you can do that now, good for you, all right? Give it a try, all right? If I look at this one, once again, I'm going to use my distributive property. I'm going to distribute this negative 3. And then over here, there's no distributive property because there's no set of parentheses. All right, so here I'm going to use the distributive property. It's negative 3 times the 4x. And then negative 3 times the 2. Okay? And then these other guys, just write them down. Minus 2x plus 6. There's nothing to be done there at the moment because I'm still doing my distributive property. Negative 12x. Here, that's going to actually be a negative. And you could write plus a negative, or you can just write minus 6. All right? And then the minus 2x, and then the plus 6. And now combine like terms. Negative 12x minus, and the minus 2x is a negative 14x. Again, include those signs when I'm looking at this guy and this guy. Include those negative signs when you're adding those things together. And then the negative 6x and the plus 6x. Well, that gives me a 0. And I could write plus 0, but really that's silly. It's silly to write the plus 0. It's just a negative 14. Okay? Last one, if I look at this guy. Again, I'm going to use my distributive property, so I'm distributing this 3. Over here, be careful. I'm distributing that entire thing. That's a minus 4. Make sure you include the sign. We don't want to drop that sign. That negative sign, that minus sign has to go with the 4 as it gets distributed. Okay? So here, that gives me a 3 times x plus a 3 times 5. Over here, that gives me a negative 4 times x. And then a negative 4 times 1. And now I simplify. That's a 3x plus 15. Here, that's a negative 4x. And here, that's a negative 4, so I can just write minus 4. If you leave this as a plus and then write a negative 4, that's okay too, all right? Because remember, adding and subtracting, we can go back and forth between the two. And if I had this written as minus 4, well, that's the same thing as adding negative 4. All right? In the previous one, I just wrote it as minus. This one, I wrote it as plus a negative. That's okay. Whatever makes the most sense to you, that's what you should do. Okay? And now I combine like terms. These guys are like terms. The 3x and the negative 4x, that gives me a negative 1x. Again, you could just write negative x here. And then the 15 and the negative 4. And sometimes leaving it as the negative like that, it makes more sense to us. Because now 15 plus a negative 4, maybe that makes more sense. Maybe it makes more sense to write it as 15 minus 4 to you, okay, which gives me an 11. All right? But again, the distributive property is just giving away that multiplication. We're giving that multiplication away to everything in the parentheses. And then look for things that have the same variables. Those are like terms. We can add those together. The variable part stays the same. Okay?